I am Dr.B.Krishnaveni, Assistant Professor, Department of Mathematics, Aditya University. So today we are discussing about the topic change of order of integration. So what is change of order of integration and why we need change of order of integration? So this is discussed in double integration. So in double integrals, what happens means whenever we evaluate the double integration as it is given in the question, some of the questions becomes complicated to do the integration part. So in such cases, what we will do is, we will change the order of integration correspondingly, we will evaluate the double integration so that the problem becomes easy in the case of evaluation part. So let us see how to do this. So hence today learning outcome is evaluating double integrals by changing the order of integration. So let me explain how to change the order of integration. So usually we will get the change of order integration whenever the one variable having some variable limits. So for example, if you are having the limits in terms of x means those are y limits. Suppose the limits are in terms of y means those are x limits. In this cases only we can change the order of integration. If all the limits are constants, then there is no need to change because you can follow any order to make the evaluation part. So now let's discuss. The first thing is, the first case is whenever we have the integration in this form, and here it is clearly that the y limits are variables and x limits are constants, hence the order of this integration is dy dx. Now to evaluate this integral, we need to integrate first with respect to y, then with respect to x. And as said already, this may sometimes be difficult to evaluate. In order to overcome this, we can change the order of integration in which the y limits are changes to constants, which are constants, and the x limits are variable limits, which are in terms of y. So hence therefore the double integral becomes in this form, that is integral c to d integral g of 1y to h1y f of xy. Since x limits are variables, need to integrate first with respect to x, then with respect to y. So that's what we need to do the evaluation easy. So hence to evaluate this integral, we first integrate with respect to x, thereafter with respect to y. This process of changing a given double integral into an equal double integral with order of integration changed, we call that as change of order of integration. So hence, this is the case which we have taken, dy dx is the order, and in this what we need to do is, we need to change as dx dy and then do the evaluation part. And we call this process is change of order of integration. Now, for doing this, we have to identify the region of integration from the limits given in the double integration. So, that means in order to change the order of integration, first of all, you have to draw the region of integration which were given from the limits of double integrals. Sometimes this region may split into two regions R1 and R2 when we change the order of integration. And hence the given double integral, that is double integral over R f of xy dx dy, will be the sum of two double integration, that is double integral over R1 plus double integral over R2. So in order to find out the double integral using change of order of integration means we need to change the order of integration. In order to do that, first of all, we have to identify the region of integration by taking the limits which is given in the question. Thereafter, we need to take the strip accordingly to given in the question. That means, I can explain this, how means, if you are given the order as, the same example we will take, or the same explanation we will take, which is given here itself. So here given region, that means here given the order is dy dx. First of all, you have to draw the region of integration bounded by these two curves and the lines. And in that region, since it is a dy dx, in order to change the order of integration, that is to dx dy, we need to consider horizontal strip. If we consider horizontal strip only, then first we will get x limits in variables and y limits constants. Hence, therefore, the order is changes to dx dy. So In this case, that is whenever dy dx is the order given in the question means, draw the region of integration bounded by the curves and the lines, and in that region take horizontal strip, find x limits which is in terms of y, that is a variables, next y limits which are constants, hence the order changes to dx dy, and vice versa. Vice versa means, suppose we are having the order is a dx dy given in the question. Same, first you need to identify the region of integration bounded by these curves and the lines. Now to change the order from dx dy to dy dx, in that case we need to consider vertical strip. So if you consider vertical strip means, first you will get a y limits in terms of y, x limits constants, hence the order changes to dy dx. So this is the way you have to follow to change the order either from dy dx to dx dy or dx dy to dy dx. So let us see the question on this. Change the order of integration and evaluate integral 0 to 4a integral x square by 4a to 2 root ax dy dx. So here clearly limits are in terms of x means those are y limits and the constants are x limits. Let us draw the curves y is equal to x square by 4a, y is equal to 2 root ax. So the corresponding curves are nothing but these two, that is x square is equal to 4ay and y square is equal to 4ax, which are nothing but the parabolas. X square is equal to 4ay, the other is y square is equal to 4ax. Now to find the points of intersection, as I said already, you can substitute one curve into the another curve. If you do that, we will get the points of intersection 0, 0, 4a, 4a. Now to change the order of integration, here we need to consider horizontal strip. Why? Because in the question given dy dx, now I need to change the order as a dx dy. So that's what, if we consider horizontal strip, first you will get x limits from left to right. So left means y square is equal to 4x, from that x is equal to y square by 4a. And the right is a touching x square is equal to 4ay, that means x is equal to root of 4ay means that is. And what about y limits from this point to this point, and this is 0, 0 and here it is 0, 4a, hence y varies from 0 to 4a. Hence take the given integration and that integration is equal to x is equal to y square by 4a to 2 root ay, y is equal to 0 to 4a. Now the order changes to dx dy. So now evaluate with this order of integration. First with respect to x, keeping y constant, that is integral 0 to 4a, integral x is equal to y square by 4a to 2 root ay dx, then dy. So first with respect to x integration, so integral ds is x between the x limits. Substitute x limits, upper limit is 2 root ay, the lower limit is y square by 4a, which is equal to integral y is equal to 0 to 4a. Substitute upper limit, that is 2 root ay minus lower limit y square by 4a dy. So now do integration with respect to y, 2 root a, y power 1 by 2 you can write as a root y, and y power 1 by 2 integration is y power 3 by 2 by 3 by 2 minus y square integration is y cube by 3, 3 into 4 is 12 into a, 0 to 4a. Now substitute upper limit y is equal to 4a, lower limit y is equal to 0, you got the answer is equal to 16a square by 3. Now the next question is change the order of integration in integral 0 to 1, integral x square to 2 minus x, xy dx dy, and hence evaluate the double integration. So here again the limits are in terms of x means those are y limits. The next limits are constant, which are x limits. Actually the order of integration is not proper in the given question. The correct order is dy dx. So since the order is a dy dx in the question, so hence we need to change the order as a dx dy. Hence we need to draw, to get dx dy we need to consider horizontal strip in the region of integration. So for that sake, first let's find out the points of intersection by taking y is equal to x square in this curve. You got this, and this were the points of intersection, that is 1, 1, minus 2, 4. Now clearly the region of integration, you can see the figure, the shaded area is giving the region of integration. The one is parabola, y is equal to x square, the other is the line x plus y is equal to the line is here, this is the parabola x square is equal to y, here it's the line x plus y is equal to 2, and the region is this, the dotted area in the figure. And here if you see and if you consider the horizontal strip, the strip is not uniform throughout the region of integration. See all of you. So here if we consider the strip at this part means left is touching y axis, right is touching the parabola. But if you take the strip at this place means left is touching y axis only, but right is touching the line x plus y is equal to 2. So that's what we need to divide this entire region into two parts, right? So that is the total area, that is OAB is equal to OAC plus CAB. So let us evaluate the double integration in each case, and finally the total will be equal to the summation of those two integrations. Now first along OAC, for the region OAC, horizontal strip we have to fix y. Now x varies from 0 to here the curve, that is root y. And what about y is from this point to this point, that is 0 to 1. Now along CAB, x varies from y axis, that is x is equal to 0 to the line, that is 2 minus y, x is equal to 2 minus y. And y varies from this point to this point, that is 1 to 2. Hence, the double integral is changed to double integral along OAC plus double integral along CAB, and which is equal to y is equal to 0 to 1, x is equal to 0 to root y, xy dx dy plus integral y is equal to 1 to 2, x is equal to 0 to 2 minus y, xy dx dy. So now do in both the integrals, first with respect to x between the limits, then with respect to y between the limits, given y limits. So which is equal to integral 0 to 1, x integration is x square by 2 between the limits 0 to y, y dy plus integral 1 to 2. Now in the second part, x integration is x square by 2 between the limits 0 to 2 minus y, y dy. Substituting the limits, you got this is equal to 1 by 2 integral 0 to 1. Upper limit is root y whole square means y, it is y into y is y square plus the lower limit is 0 plus 1 by 2 into upper limit, substituting and simplification, you got 4y minus 4y square plus y cube. Now do integration with respect to y, 1 by 2 into y square integration is y cube by 3 between the limits 0 to 1 plus 1 by 2 into, now do integration 4 into y integration is y square by 2 minus 4 into y square integration is y cube by 3 plus y cube integration is y power 4 by 4 between the limits 1 to 2. That is equal to the first part, do integration, substitute the limits 1 by 2 into the upper limit is 1 by 3, 1 by 2 into 1 by 3 is 1 by 6, and the second part, substitute the limits upper limit y is equal to 2, we got 8 minus 32 by 3 plus 4 minus lower limit y is equal to 1, 4 by 2, that is a 2 minus 4 by 3 plus 1 by 4, simplify it and you got the answer is equal to 3 by 8. So hence in this we got an idea how to find out the double integration by changing the order of integration. So either you can change dx dy to dy dx by taking vertical strip, and you can change dy dx to dx dy by taking horizontal strip. Thank you.